All right, here's a nice question. I think I'm pretty sure it is a limiting reaction question. Hi, Otto. I'm making a video. Okay, so we have a chemical reaction. Magnesium nitrate reacts with potassium hydroxide. So you're going to get potassium nitrate out of it and magnesium hydroxide. Formula looks good. Let me see about balancing. I have 2 there, 2 there, 2 there. It's balanced. Perfect. And we write down 0.156 and 0.105 for magnesium nitrate, and 0.166 and 0.106 for potassium hydroxide. And then they say what mass of the precipitate will form. So we don't know which of these is a precipitate. So I need to look off my chart, my solubility table, to see which one is a precipitate. I'll pause and find that. Okay, so here's the solubility table. And how you use the solubility table, let's do magnesium hydroxide first. Magnesium, you find magnesium or hydroxide on the top. Here's hydroxide. And then you look down either here or here to see if magnesium is there. So magnesium is not a group 1 ion, nor is it an ammonium ion. Therefore, it has to be in this category. And this category has a solubility less than 0.1, meaning that we typically call it a solid. So this one's a solid. And that's the one. Oh, whoops. This information here is on potassium hydroxide. It should be there. Okay? Because a magnesium hydroxide is the precipitate, and that's the one that we want to determine the mass for. Okay, and then just to confirm, potassium nitrate is right here, and potassium, since it's not here, it's got to be there. This one is aqueous. So potassium nitrate is aqueous. Okay, let me get rid of that chart now. We're done with that. Okay, so now, since I have information about both reactants, I need to know which one of those reactants is going to get used up first, or which is the limiting reactant. So let's find the moles for each one. So to find the moles of magnesium nitrate, I go concentration times volume. That's my formula. C equals N over V. So if I'm solving for N, C times V. So the concentration is 0.105 moles per liter, and the volume is 0.156 liters. So the liters cancel, and that will leave me with, let me figure that out, 0.105 times 0.156. Uh-oh. There we go. 0.01638 moles. Okay, now let's figure out the moles of potassium hydroxide. And again, it's the same, it's going to be C times V. So the concentration is 0.106 moles per liter, and the volume is 0.166 liters. That should have been 0.166 liters. Okay, let's multiply those together. Okay, 0.106 times 0.166. So this comes out to 0.017596. Okay, now since my ratio up here is 1 to 2, that means that for every 1 magnesium nitrate, I need 2 potassium hydroxides. So you might be able to just look at it and say, well, if I double this, it's going to be more than that. Therefore, potassium hydroxide is my limiting reactant. if you can't see that, we can do it like we usually do. I always take the first one. So I have 0.01638 moles of magnesium nitrate. Okay, and if I multiply by the mole ratio, so 2 moles KOH to 1 mole magnesium nitrate, these cancel. That would be double that, so let me figure that out. Point. Okay, times 2. Okay, so that gives me 0.03276 moles of potassium hydroxide. And that's how much I would need to use up all of this magnesium nitrate. But when I compare it to what I have, this is how much I have here, this is less than this. Therefore, the potassium hydroxide is the limiting reactant. This is the limiting reactant. So it's this one is the one that I want to use. Okay, so now let's do our solid liquid gas, moles. So I need to go from here to here, that's step 1. So step 1 is to take my concentration and volume and convert it into moles of the potassium hydroxide. And I already did that in the red step, this one right there. So my moles of potassium hydroxide are 0.017596. Okay, step 2 is to convert moles. Let's use a different color. Step 2 is to convert moles of KOH to the moles of the precipitate. And we figured that that was magnesium hydroxide. So I need to get that to moles of magnesium hydroxide. So I write down what I have, 0.017596 moles of KOH, and I'm timesing that by KOH to magnesium hydroxide. So 1 mole of magnesium hydroxide I get from 2 moles of KOH. Let me just make sure that's right. Yep, 1 to 2. Okay, so I take that number that I have, divide it by 2. Okay, and I'm going to get 0.01638 moles of my precipitate, magnesium hydroxide. Okay, and then the question says what mass of the precipitate will form. So I just did this step. Now let's do, it wants a mass, so it's a solid, so that'll be step 3 there. So step 3 is to take the moles of magnesium hydroxide and convert that to mass of magnesium hydroxide. Formula, moles is equal to mass over molar mass. I want to solve for mass. So mass is moles times molar mass. The moles I just found, 0.1638 moles times, I don't have the molar mass of that. Let me go and do that. So I have 1 magnesium, that's 24.31. I have 2 oxygens, that'll be 32 altogether. And I have 2 hydrogens, so that'll be 2.02 altogether.
Rowan's having a night terror. I need to go downstairs. Here.
Okay, so sorry, I had a little break there. 3, 6, 8, 5, 58.33. Okay, so the mass of the precipitate is times 58. 0.33. There we go. 0.95544, etc. grams. This is grams per mole. So in the question, looks like I have 3 sig figs everywhere. So it'd be 0.955 grams.